Welcome to Summarize Science. Today, we're tackling one of the biggest questions in the cosmos. How does a massive star die in a spectacular supernova explosion? For decades, the leading theory was that a shockwave stalls deep in the star, and a blast of ghostly particles called neutrinos pushes it outward, blowing the star apart. However, this neutrino model has trouble explaining the shapes of many supernova remnants we observe. Some of them look strangely symmetrical, with lobes or ears on opposite sides, which is hard to create with a uniform explosion. This has led to a newer, more chaotic idea, the Jittering Jets Explosion Mechanism, or JJM. The JJM proposes that the core of a dying star isn't calm, but is churning violently like a pot of boiling water. As this turbulent material falls onto the newly formed neutron star at the center, it forms temporary, wobbly disks. These disks then fire off pairs of incredibly powerful jets that are aimed in random directions. In other words, they jitter. It's these jittering jets, not neutrinos, that blast through the star and cause the explosion. But for this to be a universal explanation, that violent churning needs to be present in the cores of all kinds of massive stars. That's exactly what the authors of this paper set out to investigate using computer simulations. They modeled stars from 12 to 40 times the mass of our Sun, including stars that had their outer layers of hydrogen and helium stripped away by stellar winds. And their results, shown in graphs like this one, were incredibly consistent. In every single model they ran, they found at least one significant, strongly churning convective zone deep inside the core, right where it's needed to power the jittering jets. This is a huge finding because it shows the necessary engine for the JJM is a robust feature, not a rare exception. It works for the progenitors of standard supernovae, as well as the stripped envelope types, which hadn't been studied for this mechanism before. The researchers also point out that in most cases, these jets would start firing before the neutrino mechanism even has a chance to get going. This strengthens the argument that jets are the primary driver of the explosion. This leads to a really bold claim. If the JJM is correct, there might be no such thing as a failed supernova. For a long time, astronomers have thought that some massive stars might just collapse directly into a black hole without a big explosion. But this research suggests that every massive star that isn't spinning extremely fast should explode successfully, leaving behind a neutron star. So, let's recap the important points. New simulations show that the cores of massive stars are violently churning just before they collapse. This churning provides the perfect fuel for the jittering jets mechanism, where powerful, randomly aimed jets tear the star apart from the inside. This mechanism not only explains the strange point-symmetric shapes of supernova remnants, but seems to be a common feature across a wide range of stars. What this could mean for the future is a fundamental shift in our understanding of how the universe's most massive stars end their lives. It suggests all of them go out with a bang, which helps us better understand the cosmic origins of heavy elements and the populations of neutron stars and black holes we see today.